can see is the way that we've designed our system using this UML class diagram is we're saying that students take courses, right? And courses have students in them, right? And a course is taught by a teacher, and a teacher can teach courses in our system. Now these numbers tell us what our limits are. So I don't think it's shown in here, but I think it's in a couple of slides that will start describing what these specific numbers are, but I'll go ahead and say it now. As this might be understood, is the course can be taught by one teacher. Okay, so what we're saying is that a course must have a teacher and can only be taught by one teacher. So you can't have more than one teacher teaching the same course. Okay, now a teacher, now this is for a particular semester, a teacher can teach 0 to 3 courses, somewhere in between those two numbers, including those two numbers. So a teacher could teach 0 courses, a teacher could teach 1, they could teach 2, they could teach 3. But according to the way that they've set up this system, a teacher cannot teach more than 3 courses, so you can't teach 4. The 0 means that it's optional, means that a teacher doesn't have to teach any courses. Okay. A student, let's talk about the star in a second. The 5.60 tells us, by the way, the dot dot, just like it did here with the 0 to 3, is a range. So a course can have between 5 and 60 students. What that means is that a course that would have only 4 students in it could not exist in our system. We're not going to provide courses if only 4 students are in them. Also, once we get to 60, that's the maximum that number of students that can be in a course in a semester. Okay. The star. Now the star means many, and it's no limit. So a student in our system can take as many courses as they want. Okay. The star without anything on the other side of it, so is implied to be 0 ... star, meaning it doesn't have a requirement. So a student can take 0 courses, or they can take as many as they want. Okay, so that's the way we set these up. Okay, so how would we make this happen in Java code? Okay, so how could we represent that a student object has courses, or takes courses? How could we represent that a teacher teaches a course? What do you think? What are some ideas? What do you guys think? How much you show that a student has courses? Yeah, I noticed that the recording stopped, but it says that it's still recording on here. So, okay, a variable maybe. Would it have to be static though? Remember, the static variable is something that exists amongst all the classes, regardless of if we even have an object or not. Right? So does it make sense that a course, if a course doesn't exist, that it has a teacher? No, if a course doesn't exist at all, that doesn't make sense to have a teacher. Right? Also remember that a static variable is shared amongst all of the objects of that class type. So remember, if you remember back to our example from yesterday, the circle object with a static variable number of objects, all the circles had the same static variable, had the same number of objects variable, had the same value for all of them. So does it make sense that if a course had a static variable in it, for teacher, for example, that all courses have the same teacher? Do all courses at Octonese University have the same teacher? I don't teach all the courses. Thank goodness I don't teach all the courses. I'm really glad. You guys should be really glad that I don't teach the Turkish course. That would be bad. Okay. All right. Well, let's take a look because as often is the case, there's more than one way to do something. So let's take a look here. Okay. So let's say we had these classes here. Let's take a smaller example. We have a class for a name that we're defining for a name. We're having a class for a student that has a name and has an address, and then we have a class for address information. Okay, so that would mean that in this case, the way we might draw this would be that a student has a name and an address. Okay, now a student has one and only one name. Student has one address. Okay, there's only one place you live. You don't live more than one place and you don't have more than one name. Now, is it possible that the same address could belong to multiple students? What do you think? Can the same address belong to multiple students? Yeah, different people can live in the same place, right? So we might say, okay, let's put a star here to say many, right? Now, could the same name belong to multiple students? I guess it's true. Yeah, I mean, you do have, I mean, actually, I don't know if you guys know this student, but we had a student here a few years ago, older student named Recep Tayyip Erdogan. And so that was interesting. And then in the same semester, in the same class, there was a student named Cem Yılmaz. So it was kind of interesting to have two famous people in our class at the same time. So what we could do is we could say that's the same. We could also do the same thing here, star, right? Okay, now the way that we've done this is by saying if there's a 1 on this side, what could make sense is that that student, this class, has one name, right? This student has one address, so we just put a name variable in the student class. We put an address variable in the student class. All right, so let's take a look at the same thing. Okay, for the previous example. All right. All right, so let's say that we have this, I'm just going to do this kind of, what's the word, pseudocode kind of. And then we'll just call it class teacher. All right. All right. So now a student can take how many courses according to the way that we have this thing set up? Okay. A student can take 3 courses? Right, as many as they want, right? They can take as many as they want. So if there's multiple of something, how many? How can we represent something that contains lots of something? Okay, I see the confusion. I'm not talking about octanies when I say this. I'm talking about our system, this example system here. Yeah, an array is a perfectly valid way to represent that. So it's an array of what, though? What is it an array of? What's in our array? What type of things are in our array? All right, an array of courses, right? So we create a course array. All right. How big should it be? Well, it can be as big as we want, right? So, what we'll find is that an array is what you know now that can contain multiple items, but it's not really great for something like this. So later in the semester, we'll talk about other possible data structures that we can use for this, okay? But for now, we're going to call it like this, okay? All right. Now, does this satisfy this side of the requirement that a course can have 5 to 60 students? According to the way that I've defined it here, how many students can a course have? Well, as many as it wants, right? There's not really a limit to here. Right? So this is one way. We could also do the same, but on the other side. Is what we've done here is we've said, okay. What we've done here is we said, okay, a course can have up to 60 students. Now, what we would probably do is we would have some method down here to make sure that there were at least 5 students in the array. Okay. But this is a second way. So we can either say that this relationship is satisfied by putting an array, or later we'll talk about other data structures as well. We can either put a course array in the student class, or we can put a student array in the course class. Okay. Which one should we do? Which one is right? Guys, which one is the right way to do it? Some different answers here. Of course, student has courses, both is right. Yeah, you guys might have forgotten from last semester. Quite frequently when I say which one is right, it's depends, right? Conbeck, so he says that doing them both would be better. So having both this and this, we can do it that way. I can say the trade-off here. So here's basically the way this would work in terms of the trade-off. Okay. If we were to say, I want a list of all the courses that a student is taking, doing that by having a course array in the student class would make that very easy to find out what classes a courses a student is taking. However, if I did it this way, to find out which courses a student is taking would be difficult if I were to say, because then I'd have to basically go through all courses, find out if that student is in that course, and then say yes, okay, and then add that to some other structure. Okay. If I were to say, okay, well then I want to find out what students a course has. I want to find out what students are in a course. That's what I do, right? I don't necessarily, like Conberg for you, like I don't need to know all the courses that you're taking. I need to know which students are in my course, right? So this would be better for that. But finding out which courses a particular student has becomes quite difficult if this is all we do. So Conberg is suggesting we do them both, okay? Which would make finding the list of students easy, would make finding the list of courses for a student easy, but making sure that the data is consistent for both becomes hard, it becomes something that we have to do, okay? So that's the trade-off. And then later, you guys will do next year, you'll be in my database class next year where we'll talk about how databases can solve this problem quite easily. Okay, all right. But for now, let's move on to this other relationship, the teach relationship. Okay, so now to make the teach relationship, do we need in the course, do we need an array of teachers that teach the course? No, we don't need a teacher array because there's only one teacher, right? All right. Done. We're done, right? But just like the same way, if I want to find out the teacher for a course, this becomes easy. If I want to find out the courses that a teacher is teaching, this becomes hard. So we might also, or alternatively, in the teacher class, have a course array for courses the teacher is teaching. And make it limited to 3, right? Because I can only teach 3 courses. Right? So this is a way we could do these. So this is one way for that teach relationship. This is another way for that teach relationship. And just like I said before, one way makes finding certain information easy, but finding other information hard. The other way does the opposite. And then if we keep them both, if we say I want both a teacher object in the course class and I want a course list in the teacher class, keeping the data consistent, keeping them the same becomes hard. We have to have methods and functionality that will take that and make sure that there's consistency there. Okay. All right. So that's kind of how we do here. Do that. Okay. Yeah, basically there's in UML, there's an aggregation and composition. It's slightly different. It's aggregation is more like this thing has something. So for example, my car has tires, right? Composition is a more strong relationship in saying that it has this thing, but it's made up of this thing. So for example, without this thing, it couldn't exist. So for example, the human body, for example, you might say, I have a hand, or I have an ear or something like that, right? But you might say I'm composed of things like a heart, a brain, you know, hopefully you believe that, that if those things were not there, if my hand wasn't here, I would still be here, right? But if my brain was not here, or my head was not here, or my heart was not here, I would cease to exist, right? I would not live anymore, right? And so that's maybe a difficult understanding there, but that's kind of the difference between aggregation and composition. Aggregation means this one thing has something else. Composition means it's made up of it, like it has to exist in order for the thing to exist. Okay. All right, we can have some what's called recursive relationships. So for example, you might have a person has a supervisor. So, you know, we have a person, me, has a supervisor, Meli Hoja. Meli Hoja has a supervisor, right? Shukra Hoja, right? Shukra Hoja has a supervisor, the rector, right? The rector has a supervisor, probably someone in the government, right? Eventually you get up to the president of the country. Does the president have a supervisor? I don't think so. I don't know. All right, but you get the idea here. And we can keep track of who a supervisor for someone is by a supervisor for someone by a single variable. That's and just put them in there, right? Okay. All right. We might also say that if someone has more than one supervisor, sometimes you have multiple bosses, right? Or a person that might be overseeing multiple people. We might have an array of that, array of person objects to be able to have that. Okay. There's a couple of other examples. We will go through those next week. We'll talk about those next week in class because I'm running out of time to do examples here today, which was expected. So here's an example of the course class here. They said, let's keep an array of students, not in student objects. Instead, it's just going to be the names of the students for the course. All right. Let's skip through some of this stuff. Okay. I do want to go ahead and finish off on wrapper classes. I do want to hit that today before we end our time together, because this is an interesting thing that Java gives us. So all of the different numeric and Boolean and character types that are primitive data types have what's called wrapper classes. The reasons why we have those is so that we can use them in things like, we'll get to this, called array lists and other data structures that require object types to be put into their as their individual items, but we want to be able to use primitive types also. Okay, so all of the different data types have what we call wrapper classes. So a Boolean is just you uppercase the B. Okay, int, its wrapper class is integer, you uppercase the I. Long, float, double. So some of you have used these classes before, like double.parse double, integer.parse int, things like that. Character.to lowercase or to uppercase, right? We've looked at those. So all the different primitive types have wrapper classes where we can put a primitive type into an object and use it for things that we need objects for. Okay. Some of the different methods and methods and static variables, constants, things like that. Attributes that exist for the say, for example, the integer and double classes, right? So this, we have a constructor where we can pass it an int value, or we can pass it a string that represents an integer. Same thing with the double, a double value or a string that represents a double, right? Notice we also have a few static methods we can use, like the parse int, which you guys have used before, some of you. The parse double, which some of you have used before, right? One thing that we'll get to later in the semester, we'll talk about this toString method, that all classes have a toString method, and we will talk about what it's used for and why it's there, because it has a very specific, it has a very good purpose that we'll use it for. All right. Notice we can also store the max value and min value for an integer and the max and min value for a double as well here. So all of them have constructors, constants, conversion methods for how to convert between two things. So it's like getting the long value of the integer, the float value, the double value, all these things, so that we can convert it into something else for use in other operations. We also notice that numeric types have a compare to. This is going to be very important for when we start talking about sorting and how we can do sorting, that we have to have the things that are in the array list or the array for the purposes of sorting it must be comparable. They must be comparable to each other. So the integer class will have to have a compare to method so that it knows which is greater, which is less. Is there anything else specifically I wanted to do? So this is ways that we can have the constructor classes, right? One thing that you'll notice, it's set up above. I didn't point it out, but you'll see a couple of slides ago, it says that none of these wrapper classes have no arg constructors, and there's a reason for that, and we'll talk about how the no arg constructor, how we get rid of it, okay, or why it doesn't exist. I think, let's see, this is all stuff for the wrapper classes still. Okay, one thing, so we'll end here on this slide. One of the things that's nice about these wrapper classes is that the conversion between the primitive type and the wrapper class type are done automatically. Okay, so if I wanted to create an integer, notice this is not an int array, this is an integer array, the class type. Okay, if I wanted to do it using 3 integer objects, I could do it like this. If I write it like this, the compiler and executor automatically does what's called the boxing, right, into the object types on its own. I don't have to make this a new integer object. I can just give it the integer primitive type, and the JDK, the Java Development Kit, automatically creates the object from this for putting into the array. In the same way, when I go to unbox these, when I go to use these as numeric types, it does the same thing. It unboxes them back into a primitive data type for adding them together. Okay, so that's kind of great actually that it does that automatically, and I don't have to get the integer value from here. It automatically does it on its own. Okay, all right, so like I said, I wanted to end there on the wrapper classes. The next slide we'll move into on Wednesday is we'll talk about big integer and big decimal, which are ways that we can represent much larger numbers. Because remember that, we go back here all. Yeah, the max value, min value, an integer type, an int, has a maximum value that it can be, right? It can't get to be above a certain amount. But what if I want to represent something bigger than that? I could do a long. I guess I could do a long, but even that has a maximum. But if I wanted to do something even bigger than that, if I needed to be able to have huge, huge numbers, maybe representing things like Avogadro's number and stuff like that, then I'm going to need something that can do that with, and that's when we're going to get into this thing called the big integer and big decimal value. Okay, all right. Are there any questions before we end our class here today?
Are we gonna make examples?
I said I would put examples on Wednesday, so I'll do some examples for this on Wednesday.
All right, thank you.
Because I feel like we ran out of time to do that today and have any good examples. Good question. Okay. All right, guys, have a good weekend. I think your labs should be starting tomorrow, so make sure you attend those. And if you have any questions, let me know, and I'll see you guys on Wednesday.
Thank you, teacher.
Thank you.